All right, so today we're gonna learn about Docker, and Docker is something that we're gonna be using throughout the course. Um, I would put it in the same category as like Git or something like that, where it's not really code, but it's an important part of the code ecosystem. Um, has anyone heard of Docker? Out of curiosity, have would anyone be able to describe what it is?
Isn't
I
it
know it's a
something you can use
container.
to set up? Oh, sorry.
Go ahead.
Yeah, what Jordan said, it's a container where you can put in different versions of different coding languages. If you're working on different programs in different, for example, versions of Python, you can have a different Docker for each version and then work on it in there.
Okay, Jordan.
Yeah, containers. My work has used it to spin up like their Drupal website on a local host.
Okay, yeah. So, what is a container? What is that?
I think it's like similar to virtualization where you break up your device's resources in this specific separate containers, and then you can like have processes run. Like you can allocate RAM and or just resources to run certain processes, and nothing else can really touch those processes. So it's like in its own container,
Mhm.
like a virtual machine almost.
Yeah, yeah. So, I'd say yeah, it is like a virtual machine. So, I would say conceptually, it's like having another computer on your computer. Um, why would you ever want to do that? Um, we'll talk about that in a sec, but before we get into Docker itself, I what I'm going to do is I'm going to go on AWS and I'm going to rent a computer real quick. You guys are going to end up doing this later in the course, but I'm just going to do it now. This I'm going to log into my AWS account. Just give me, I'll do this off screen real quick. All right. So has anyone heard of AWS before? Amazon Web Services? Yeah, so it's a cloud provider, and cloud just means a bunch of computers that you can rent. Um, so that's basically it. So I'm gonna rent a computer, and that in AWS lingo, this is called EC2, so Elastic Compute, or I forgot what the exact acronym stands for. But I'm gonna rent a computer. So I'm gonna go to launch instance. And I can give this a name. So I'm going to call this computer. And you can choose an image. So you have all these images like Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat. So these are basically like computers. Like, on your computer, you have an operating system installed and a bunch of other stuff that comes kind of default. Like you get a Mac or a Windows machine. And you can do the same thing here. So you can basically, you know, I'm going to rent a computer, and what operating system do I want installed on? So you can choose that here. So I'm going to choose Amazon Linux, and I'm going to choose this, a very small computer. You don't need to worry about any of this right now. And so I'm gonna rent a computer somewhere. I don't really know. I have no idea where it is. I guess it will be in US East 1, so it'll be maybe in Northern Virginia, but I don't really know where it is, and I don't need to care. So all those details are abstracted away. But once I create this computer, I rent this computer and install the operating system. I would like to access the computer, right? I want to go in and be able to do stuff on it. And in order to do that, with any kind of security, you basically need to create a key pair. And a key pair is basically gonna, so on the computer that I rent, it's gonna have, it's pairs, so there's two of them. It's gonna have one of the keys, and I am gonna have another key. And when I try to log into this computer that I've rented, it's gonna know that I'm authorized to do that. Don't need to worry about the details, but I'm going to create a new key pair here, and I'm going to call it my key pair. And we can see actually. So I have it downloaded here. So what I'm going to do is I'm going to drag this over here. And do this. So here is that key. So this is just a bunch of gibberish, basically. And the same thing actually works when you go to a website, for example, GitHub. You should be able to go here, and this connection is secure. Let's see if I can find the certificate. We can find the actual certificate. Use the yeah, I don't know if I can actually see the certificate. I should be able to, but I have to mess around with it. But here basically are all of the contents of the certificate. So this is the exact same thing. When you have an HTTPS website, secure website that's encrypted, they're using the same thing. There's a key pair, a public and private key, and that's how the encryption happens. So we're going to use the same basic technique, except we're just going to have our own. It's just private. It's not connected to any other networks. No one else needs to know about this. Okay, so you go here. I have my key pair, and you don't need to worry about this. And I'm going to launch the instance. So it'll take a minute or so to spin up. And what I'm going to do now is it's still spinning up, but I'm going to connect. So when I connect to this other computer, I'm going to use something called SSH. So if you've ever heard of like SSH, or I'm going to SSH into this machine or whatever, that's what we're going to do. So basically, just there's an IP address associated with this, which is right here. So this computer has an IP address, so I can go to that address, and I'll connect on a specific port. We'll talk about all of this later. I'm going to connect on a specific port, and then I should be able to go into the computer. Here, there's some of it. You don't need to worry about these details right now. But I'm going to do it. All right, so I think this should be spun up. It's running. Okay, so it should be ready. Should be ready to accept a connection now. So from my terminal, I'm going to run this command, I'm going to use SSH, and I'm going to provide it my credential, which is this key pair, and here's the address of the computer that I want to connect to. So I do that. I'll just type in yes. And now here I am. I'm connected to that computer that I've rented. So I'm not really on my computer anymore. I'm on this other computer that I've rented, and I can do things like ls. I can do pwd. I can cd. And now I can do ls. So cd to user. So I'm back where I was. But this is a Linux machine, and I can run normal Linux commands, echo hi. Okay. So now let's say I have this basic computer that I've rented. Now I want to customize it. I want to install some program. So it's pretty easy to do that. Every Linux distribution will be slightly different, but basically the same. So what I want to do is I want to install a command line browser. So when we have browsers, obviously for almost everyone, you have a GUI interface like Chrome or Brave or Firefox or whatever. And you go there and you type stuff in, blah, blah. You get a nice convenient interface. You can use a mouse, all that stuff. But you can they also have browsers in the terminal that doesn't require a mouse. So we're going to get one of those. And one is called links. So I'm going to do yum update. You don't need to worry about that. So sudo yum update. So yum is a package manager. It's kind of like brew on your Mac. Okay, so I'm going to do yum. I'll probably have to do super user yum install links. Okay, so now I've installed links here. So I can now use links to visit a website. So I'm going to do links and then example.com. And here we are on the actual website. So I'm going to go in my GUI browser and do example.com. And here's what that looks like. And then in the terminal, we get the same stuff. Okay, so I'm really not on my computer. I'm on some other computer that I've rented. I'm accessing it through the terminal, and then I can treat it like my own. I can install stuff. I can do stuff with it, whatever. So I'm gonna exit, and I'm gonna come back. I'm gonna disconnect from that remote computer, and I'm gonna come back to my own computer. So now I'm back on my regular boring local computer. I'm gonna go ahead and kill this because I'm off the free tier now. Okay, so now let's say that I wanted to create that computer to do something like serve a website to people or something like that. We can also do the same thing locally, except maybe I don't want to, I want to have an environment, a local environment where I can test the application that I want to run and have it be exactly the same. I want it to have the same operating system and the same dependencies and the same everything else, right? So if I try to install links on my local machine now, it may or may not work, but there might be conflicts with other things, or I have a different operating system, or I'm on a Windows machine and I want to run this on a Linux machine, blah blah blah. So there's all kinds of little variations that it can create problems. So what you want to do is basically have a similar kind of isolated environment on your local machine where you can run stuff and do things. And then you can also do the same thing. You can mirror that on an actual machine somewhere else that you're actually going to use. So to do that, we can use Docker. So I'm going to do the same thing. I'm gonna basically create an Amazon Linux computer, and I'm gonna install links on it. So I don't have links. If I do, I don't think I do. Links example.com. Yeah. So I don't have links on my local machine, but I can get it without installing it locally. So it's like a virtual environment, right? If I want to use pandas, I don't just install pandas on my local machine because there's a million versions of pandas that require different versions of Python. And if I have a particular project that I'm building that has all kinds of other dependencies, you want to keep all that isolated in a virtual environment. Okay, so what you need in order to do that is something called an image. So we're going to go to Docker Hub. And Docker Hub is like GitHub. It's basically just a place with a whole bunch of images. You can think of an image as basically it's like a model for a computer. So I'm going to do Amazon Linux 2023. Okay, there we go. And so here is an image which is going to allow me to basically run Amazon Linux on my local machine. So I'm going to follow this command right here. So Docker pull Amazon Linux. Go right here and run this command. And it's going to download this operating system basically. So depending on what you're doing, this may take more or less time. Okay, so I've just downloaded this Amazon Linux image. How do I know that it's there for sure? Well, I can run a Docker command. So I can do Docker images. And this will show me all of the images that I have on my computer. And I only have one right now, which is this Amazon Linux. Okay. So now what I want to do is I have this image. Now what I want to do is spin it up, basically. I want to run it. So it's like turning on the computer. So I'm going to go here and I'm going to Docker run. So run is another Docker command. And I'm going to pass it a couple flags. This is basically the equivalent of SSHing into the machine. So I'm going to do Docker run and -it. This is a flag that will just allow me to connect the terminal. And then the image name is, I'll use the image ID here. And then bash. So this is a common thing that you'll probably run. So I just want to spin up the image and connect to the shell. That's it. So I'm going to run this, and now I am I'm basically SSH'd into this machine. So I have my local machine, and then I have this Docker image running, which is basically like another computer, which is separate from the rest of my computer. I can do ls in here, and I see I have a bunch of stuff. And if I try to do, so I'm going to do, what is it? Cat etc. Let me see right here. So I'm going to cd etc first, ls. I forget what the thing is. You should be able to see what the operating system is. Maybe it's this one. Yeah, OS release. So I'm going to do cat OS release. You can see that I'm actually on Amazon Linux. So Amazon Linux 2023. So I don't have this, my actual machine is running Mac OS, but this, virtual machine, this container is running Amazon Linux. Okay, so I want to use links now. So I can do links and then example.com. And I haven't installed it yet. So I can install it. I'm gonna do the same thing. So yum update. Okay, and now I'm gonna do yum install links. And now I can do links. Actually, I'll just up here, example.com. And it works exactly the same. So now I have a local computer, which it has the Amazon Linux operating system installed on it, and I have links installed. Any questions or comments about that so far?
Yeah, my question is on space, right? Is Docker consuming the amount of space that it has installed in it on your computer, or how is that?
So you can see the size of an image. So I'm gonna exit out of this real quick. And exit. So now I've exited from the container, and I've basically like disconnected from the container, and now I'm back on my host machine. I can do ls, and there I am, and I can do Docker images again. You can see the size of the image right here. So this is a relatively small image. Many are much larger, some are smaller. So you can, for example, Alpine. This is another Linux distribution, which is like the smallest one. So I'm going to run this, and we'll see how big it is. So Docker pull Alpine. And Docker images. You can see that's only 7.3 megs. And if I did Ubuntu, so Docker full Ubuntu, this might take a little longer. Actually, this one's a little smaller. But on Docker Hub, there's a whole bunch of different images. Sometimes these are like base images, kind of just have the operating system. But you can also have images that have the operating system and Python installed, for example, or all kinds of other things. But I would say that's pretty much what Docker is. Docker is a way of kind of having another computer on your computer, and you can do anything you want with it, and it's separate. It's also totally disposable. So if I do Docker PS, I don't have anything, but so Docker PS is going to get like running instances. PS-A, I passed the -A flag. So a lot of what you're going to be doing is looking up stuff, looking up commands and things like that. So Docker PS-A. Here is the instance of this image. So an instance of an image is called a container. So some of this terminology is a little confusing, but so here's a container, and sorry, a container ID. The actual image is from Amazon Linux right here, and the random ID that it gives is D37 blah blah blah. And here's the command that I ran when I ran it, which is bash blah blah blah. So I can also do the same thing. So I'm going to run that same command again. I'm going to run the image again. This time I'm going to open another and I'm going to do Docker PS. Docker PS, and this time I can see this running. It's currently running. So this container is currently running right now. And you can see that with Docker PS. This is the live, what's actually running right now on my computer. And there's a couple categories. It gives it a random name and so on and so forth. Okay. So I'm going to exit. And if I run now Docker PS again, I get nothing because I stopped this container. If I do Docker PS-A, I see that I now have two instances that I ran with that same container. Okay. So that's the basic idea. Conceptually, it's just another computer that you're running on your computer. And I can, delete these. Again, these are totally dispensable. So for example, I'm going to run this again. So I'm going to create an instance. So this is a running instance, and I'm gonna add a file. So touch my file. I do ls. I can see that my file exists. So I'm going to exit this, and I'm going to run this again, and I do ls. My file is not there. So I've basically created, it's like creating an instance of a class. And if I create an instance of a class and I modify some, instance property and then create another instance of a class, that instance isn't going to know anything about that, right? These are totally separate things. So this is all ephemeral. So anything that I do in this container, once I tell it to stop running, it's gonna disappear. All right, so let's look at the README, and I'm gonna quickly walk through this. So the general concept is it's a computer. It's another computer that's running on your computer. Let me open VS Code. So I'm going to do a couple things. I'm going to create a Python file. And I'm going to do print. So this is Python 2 syntax, right? So if I try to run this with Python 3, it's gonna not like that, right? So on my host machine, I have a specific version of Python, which is 3.11.4. But in order for this to work, I'm gonna need Python 2. So I could install Python 2 on my computer now, which might be fine or might not. It kind of depends. But in either case, I just need it to run this program, so I don't really need Python 2 on my host machine. So what I can do instead is I can create a Docker file. And oops. A Docker file is just a description of the computer that you want to run. So I'm going to take this line first, and I'm just going to I'm gonna do what I did before, which is I'm gonna download the image for Python 2. So Docker pull Python 2. So the format for this, here's the base image, Python, and then there's a colon, and then this part here is called a tag. So this will be like, Python 2, Python 3. And if we go to Docker Hub, we can take a look at those. So there's a whole bunch of these, different versions of Python with different versions of operating systems and so on. So there's a lot of possibilities. And this is important, for certain applications where you want to have like, here are the exact requirements of this application. I've tested it on this exact version and I want this to run all the time because I'm sure that this works. Rather than, I developed an application and then I'm going to install this on a bunch of different servers with different operating systems and different versions of things. And it's just gonna cause problems. So you want to maintain that consistency where once I have something that works, I'm going to lock it down and then I can be sure that it's going to work anyway. So I'm going to do Docker images and I can see that I have this new image now, Python 2. So I'm going to go ahead and basically SSH into this container. So Docker run -it and the image ID 68. You don't have to pass it the full thing as long as it's enough to be unique. And then bash. Okay, so now I'm inside of this Python 2 container. I can do Python -- version, and it's Python 2.7.18. Okay, so I'm going to exit. I'm going to go back here. So a Docker file is basically a way of formalizing that. So what I just ran on the command line is kind of like a one-off thing, right? But I want to formalize this and have it, have it be something that I can check into a repo so everyone has the same thing. And that's what a Docker file is for. But I'm saying that the computer that I want to build, I want to start from the Python 2 image, which we just saw here. And then you can also do a bunch of other customizations, right? So I'm going to start with this base image. And then I also want to do a couple other things, right? Because I don't just want this operating system with Python. I actually want to have this, I want it to run this specific program, right? That's why this computer exists. The computer exists in order to run this hi.py file. So you actually don't even need to do this. So I'm going to skip this for now. Just the simplest possible thing is from Python 2, and I'm going to copy over whatever I have here, this local hi.py, and I'm going to put it onto the other computer. So actually, I'm going to go ahead and demonstrate that. I'm going to go back to AWS. Sick. I'm going to create another instance real quick. Launch it. It'll take a minute to spin up. And so what I'm going to do is I'm going to SSH into this remote computer just like I did before, and then I'm going to copy a file onto that computer. Here, create a new I'm going to SSH into that machine. Okay. Now I'm going to exit. And I'm going to create a file. Okay, now what I want to do is I want to copy this file onto that remote machine. So I'm going to SSH back into that and ls, just so we know that there's nothing there. pwd, home ec2 user, exit. All right, so now I want to copy this over. So the command for that is scp. And also, it's basically going to be identical to the ssh command. So I'm going to go over here. So scp, blah, blah, blah. And then ct user add blah. So the file name will go first. So the typical format for Linux or like command line stuff is from and to. So from goes first and then to goes second. So from my file, I think that's what I called it. And then this will be here. And then I'm gonna need a colon slash home slash ec2 dash user. Okay, so I just copied this file from my local machine onto that computer that I'm renting. So now if I SSH back into this and do an ls, I see that this file is now here. So I have a local file that I just copied onto this remote computer now. So I'm gonna go ahead and destroy this. All right, so now let's go back to right here. So what we're doing here is the same thing, except we don't want to have to, manually go in every time we create this image and copy it. We're just going to say this is part of what you have to do. This is part of the setup for this computer. So we're going to copy this file over from the local host machine into the container. And then the CMD, the command part of this is what do you want to happen when you run the image by default. So because the whole purpose of this program is to execute this script, that's what we're going to put in the command. So when we just run the image, it's going to execute the script. All right. So we have this Docker file here, which is a description of the computer that we want and any additional customization. We could also install other things here, but we're not doing that in this case. So now we're gonna build the image. So we have a description that we want in the Docker file. Now we're gonna actually build the image. So Docker build, and then we can give it a name with -t. So Python 2 image. Actually, I think it's gotta be lowercase. And then the other argument here is a path to the Docker file. So dot, and Docker is smart enough to figure out that if you say dot, it's going to look in the current directory for a Docker file. If it finds the Docker file, it's going to use it. So now I'm going to go back to my terminal here and do Docker images. And I can see that I have this custom image that I just created. Python 2 image. Okay. So let's take a 5-minute break and then we'll come back and finish this up. So Phil, what kind of questions would you get?
Uh, they were good. I actually liked them a lot. But they were mostly string and array manipulation problems. Um, I know that the like as far as like the leak code thing, it felt like a standardized test for they gave you like almost triple or quadruple the amount of information. Like no problem is like build a function that does this and like kind of tells you what to do.
Yeah.
Instead, they've got like a story, lots of constraints, lots of like unnecessary data. And I think that's like a big thing they're looking for is, can you read this problem? Do you understand it? And can you translate these instructions into pseudocode? And then can you translate your pseudocode into actual code? And so like at least for all four problems, I couldn't see any valid like help if you were like, oh, I know how to use a hash map really well, or I understand like sliding window. None of that would have really helped you for anything in particular. I know the fourth problem they wanted you to optimize. I solved it not optimized. I was trying to come up with figure out how to implement the optimal solution, but they gave me an array of two different arrays of numbers, and they wanted to know the largest common prefix between any numbers in the arrays. So I think what I did is I sorted both of the arrays and then I iterated through them, converting the element to a string. And then it's like what I did was actually zip the two iterables.
Yeah.
And so I compared string characters, but like my solution was probably like O of n to the third or something like that because of or actually it may have been O of n to the fourth because you're converting to a string and calculating. But yeah, it's like I think the fact that I solved it and told them an optimal solution. One thing that felt good is like we were in that Discord, so there's lots of people waiting and saying stuff. But Kenny and I were actually like the first people I think to hear back. And then as soon as we started telling people that we got accepted, other people started saying they either got accepted or haven't heard anything since.
Yeah.
But I know I felt really good. The first two problems I solved were like 100%. Like I read the problem, wrote the pseudocode, wrote the code, and then submitted, and it was 100%. So it was like,
Nice.
I know most people didn't solve two problems. So I think Kenny and I were one of the few that solved two or more. So like that felt good too. But yeah, it was really I definitely felt a little off guard with the questions. I wasn't kind of expecting it to be like that, but it does seem like a fair and reasonable process.
Yeah, part of me wonders if they do that as like a anti chat GPT measure.
Well, I know that, like when we had to take the assessment, you have to have a webcam on you, and your mic needs to be on, and then there's like lots of rules for how you're allowed to be set up. So it's like if you even did find a way to cheat, it would be very hard to figure out a way where you're not looking suspicious on camera for over an hour.
Yeah.
But yeah, now we're both freaking out. We need to touch up our projects and go over some things. I was actually looking at my Pokemon project a little bit last night. Because I know there's still like a small issue I had where the way that I set up the backend fetching to like start the game is like not ideal. There's like a lot of mutation going on and a lot of things that are not very functional. So it's like I have one fetch that gets all the Pokemon, and then it gets a list of like all of the names and all of the moves, and then it makes 150 other fetches like based off of the names in that list. And then when it makes those fetches for each Pokemon it's getting, it now has the information to build everything. So it creates a a Pokemon with moves, essentially, or random moves. And I'm trying to think of whether I should try and put that in a JSON fixture, or another way around it. But I started a project with some people from another boot camp, so we'll see if we get that done on time.
Cool.
Congrats on round 2, Philip.
Thank you, thank you.
Yeah, it's a bit of a grind though. I'll tell you, your first job is the hardest one. Hardest one to get.
Yeah, it's really it
I think
takes so
there's-
much work to get into the room just to tell someone why you're valuable.
Yeah, the good news is like the easiness is an exponential curve. Like, you know, your first job is way hard, you know, inverse, whatever. But yeah. So you just gotta suffer through it, and once you do it, you should be pretty much good. All right. We'll keep on going with the lecture. Any questions about Docker, whatever SSH stuff so far?
I got one question, Chad. How did you know which version of Python you were getting when you just used the tag 2 for that? It seemed like there was a crap ton of them.
I'm sorry, could you ask that question one more time?
Oh, yeah, sorry. When you did the Python with tag 2 for the image, like how do you know which version of Python you're getting on that? Because there was like a crap ton in there.
Yeah, so the tag will actually tell you the specifics. So in this case, the tag 2, you know, whoever maintains this this repo for the official Python image, they just said 2. So there's, you know, Python 3. There's if you do just Python, there's actually a default tag, and the default tag is latest. So if I do this Docker pull Python, so let me show you in the images here. So notice that the tags are all latest. So I just did Docker pull Ubuntu, Docker pull whatever. Here's where I pulled the specific version with a specific tag, and it shows up here.
Are you
So-
able to update the images if there's an update, or do you have to do a whole new pull?
You would have to do a whole new pull. You could also, you know, if you have an image and you want to install some other stuff on it, you can do that as part of the Docker file. So if I wanted to, let's say, so I'll comment this out for now. I'll create another Docker file. So from Amazon Linux, and there's no tag here. So I by default, it'll just be the latest tag, which is fine for what I want right now. And I'm going to do run, and I want to install links. So I'm going to do, I'll do yum update. So this is like the same command that I ran on the terminal inside the machine, right? So yum update. I'm going to do it on one line here, and yum install links. And then I'm going to do cmd. And it's a little awkward here, but you have to, each individual word in the command is a separate argument in this list. So I'll do links, and then example.com. Okay, so now I'm going to build this image, and I'm going to give it a tag. Links. This. So it's building, and now it's running this command. So it's going to take a second because it has to install this thing. Okay, So this is a common problem when you have Docker images where it requires some interaction, right? I have to say yes or no. So you can actually add a flag here, -y, and that will automatically answer yes. So I'm going to build this again. Okay, so if I do, I'll go back, I'll switch to this with easy to read. Docker images. I now have this one that I just, this custom image that I created from the Docker file. So if I do Docker run links, I go to this, right? So I have this, computer that I made that I customized, and I started with a base image, which is Amazon Linux. Then I did some custom installation with this run command. So I installed links, and then why did I create this container in the first place? Because I want to run this command. And so when I do Docker run, it executes links, goes to example.com, and that's it. Okay, so we're back to this Python example. So now I should have I've built the image already. So I built the Python 2 image. So I'm going to just check that, Docker images. And I have my Python 2, which is right here. So now I'm going to go ahead and run this image. So Docker run. So run is going to spin up the image and then execute the command that I specified. So Docker run 6.8, whatever. And did not. Let me see. Let me just double check this. Python 2 image. Oh, okay. So I ran the wrong image. But the image I actually want to run is this one, Python 2 image. I'm going to do Docker run, and I can give it this, and it prints out hi there. Again, that's different because when I tried to run this locally, if I do Python py.py, I get an error because on my host machine, on my laptop, I have Python 3 installed. Here it works because it's running 2. So that's the basic idea. You start with some base image, you customize it. You can copy files in, you can run other commands to install other things, you can change permissions on file. Anything you can do, you can kind of specify and save it in the Docker file so that every time you build an image, you're going to get the exact same result. And that is pretty much it. There's a whole bunch of other commands. So building images and running images, that's 90% of what you're going to be doing. But you can also do other things. So I'm going to go back here and I'm going to start with, I'll just use the Amazon Linux image. So I'm going to run it. And I'm going to attach, let's see, Docker run -it. So I'm going to specify, I'm going to connect to the terminal here and Linux and bash. Okay, so I have this container, it's running. If I do Docker PS to get all of the running the running instances. I have one running. And so I could do something like echo hi, right? So I'm in this container. I can do any normal Linux stuff. You can also do something called exec, which is basically, I just want to execute a command directly on this image. So I can do docker exec, and then I give it the container ID. So which instance do I want to execute this on? And then the command will be echo hi. So I ran this command echo hi on this instance right here. So occasionally something like that can be useful. You can also, copy files from a running. I can do docker cp my, do I have that? Yeah, my file, and I can copy it onto, let's see. I'm not sure if it'll let me copy it to the root, but let's see. So docker cp my file, and then the container, do this. Okay, so now I'm gonna ls here, and I see that my file is there. So this is just what I did when I had a remote server that I rented, and I copied my local file from my local computer onto this other thing. It's the exact same thing. So
Whenever
that's,
you're creating containers, do you leave them in the same directory as your project, or do you have like a Docker containers directory that your projects point to?
yeah. So that's a good question. When you're building an image, like using a Docker file, then it matters because when you build it, the build command has to know the path to the Docker file that you want to use. So in that case, it matters. But when you're actually running containers or stopping them, it doesn't matter. It doesn't matter what directory you're in. So exit. So here I'm in Docker. I happen to be there, but I'm gonna cd, a couple levels down, and I can run the exact same command. It doesn't matter. So that's the basic idea. And I'm gonna let you guys play around with it. You'll have to look things up. Should be pretty straightforward. We'll take a couple hours and do this challenge. We'll see how far people get. Don't get stuck on anything for too long. If you get stuck for too long, please ask for help. Stop recording.